So, hi everyone. My name is Manasi, and I'm currently working as a solutions architect here at QuickSight and AWS. I come with a background of 6 years in data analytics and engineering, and I'm really looking forward to today's demonstration and answering any questions related to Q and scenarios if there are any. So let's go through today's agenda. I'll start off with a quick introduction to Amazon Q and QuickSight. Then I'll walk you all through scenarios, capabilities in QuickSight, post which I'll provide with some background on the use case and the data that we'll be using for the demonstration. And finally, I'll demonstrate the scenarios, capability, and share the learning resources that you guys can utilize. We'll definitely keep some time at the end of the presentation for Q&A. So with that, I would like to start by bringing a point forth here that is that AWS's long-standing commitment to AI and ML that definitely shines through QuickSight, where we first launched Q using large language models. Now, Amazon Q brings advanced generative AI technology to QuickSight. So, what you basically get is a generative BI assistant that you can use to build BI dashboards, visualizations, and some complex calculations in minutes, all while using natural language. So let's dive into the specific capabilities of Q in QuickSight. The first set of capabilities are focused on enabling analysts to build dashboards and reports faster. Next up is storytelling, which allows business users to share findings in presentation ready formats to aid decision making. Next is around enabling all users to quickly ask and answer questions against their data. And lastly, many of these capabilities can be embedded into your own customer facing products and internal facing applications. Moving on to the new capability that we saw on the previous slide, which is scenarios. Now, with Amazon Q and QuickSights, users can use scenarios to analyze complex business problems with simple natural language. It not only empowers users to perform advanced data analysis, of course, without needing any specialized skills and trainings, but it also enables you to dive deeper into the data more than your spreadsheets can allow. Scenarios can help automate tedious, error-prone, and inefficient manual tasks, but it'll also help you to modify, extend, and reuse any of the past analysis just so that you can quickly adapt to any business changes that come across. So scenarios it definitely provides like a better way to discover insights that the traditional tools can't match, and you can even perform advanced analysis, finding the answers you need to make the right call for your businesses. I would like to reiterate here that you do not need any specialized skills or trainings, and you let the QuickSight do the Amazon Q and QuickSight do the heavy lifting for you to provide you with the details in the responses. So transforming it allows scenarios also allows you to explore new possibilities by transforming curiosity into a competitive advantage. It allows you to, if you're wondering how you can spark growth within your organization, you can use Amazon Q in scenarios to analyze all the angles and provide valuable research suggestions, some comparing alternatives, and even uncover some opportunities others might miss. And with that, so what we are looking today is we will be building our demonstration in scenarios around the public sleep and lifestyle study by a public health institute. So what their use case is like pretty straightforward. What they want to do is they want to see how lifestyle factors like diet, smoking, alcohol consumption, and geography can impact sleep quality and heart health. What we have here is global data of 500 individuals over a period of 30 days with 17 demographic and sleep and health related metric fields. The field consists of categorical, numeric, Boolean, and date data types, and they range from gender, country, sleep duration, quality, date, BMI, etc. This is so like here's the quick preview of the data. What we can see for one person, we can see that we have changing daily metrics over a period of 30 days. A point to note here is that all the names and the data points we have are fictitious, which means that they are generated using AI prompt engineering and are going to be used only for this demonstration purpose. So I'll take a moment here to see if there are any questions about the data set that we are going to use before I proceed with the actual demonstration. All right, I don't see any questions, so I'll quickly move on to the demonstration right here. What we see here is a dashboard that is built in QuickSight. It's a sleep and lifestyle study dashboards built on the data that we just saw. We have some KPIs here that give us information about sleep duration hours, steps taken, BMI, and resting heart rate of given individuals. Um, Apart from this, we also have line charts and maps, some forecasting visuals, some scatter plots, additional details, Skanky charts, and even some waterfall charts and heat maps right here. Now, I am somebody who already has built a dashboard to get what all the insights that I need from the data. But what about generating understanding patterns that exists within the data on which this dashboard has built? What about some alternative scenarios, some other opportunities that I might not be able to analyze just by looking at this dashboard or by making use of the controls that are given to me to utilize this to navigate through this dashboard? This is exactly where I'm going to rely on the scenarios capability of QuickSight. You can build a scenario either in two ways: directly via the dashboard by using the Q build feature to build a scenario, or what you can do is you can go to the QuickSight homepage, and in the left options pane, you can choose scenarios, and you can click on new scenarios button right here. When we open the new scenarios page here, we see that we have a top rail which is in black color that allows us to rename a specific scenario. I'm going to sleep and lifestyle study demo. And it also allows us to rename by using the menu bar options and plug in the data that we would like to find deeper insights on, as well as some controls to navigate through the map as and how it grows. So this is the scenarios playground we have. And to begin any analysis, what we need is number one, a prompt or like a problem that we are trying to solve, and and what analysis can be performed on the data that we are going to plug in. So the second thing that we need after we have added this prompt, and the prompt is pretty straightforward. A National Health Research Institute wants to use the sleep and health data set to study how lifestyle factors like diet, smoking, alcohol, and geography can impact sleep quality and heart rate. By analyzing time series data across the demographics, their aim is to identify patterns, correlations, and alternative possibilities. So, this is our goal. And once we have, this can be as lengthy as I've sent it, or it can be as short as just typing in identify patterns, correlations, and alternative possibilities. I just like to be thorough, so I provided a bigger prompt. No, now the next step is we will plug in the data here. There are two ways we can add data to generate insights on, and one is directly from the dashboards. Um, as we can see, not only we can choose multiple visuals from a single dashboard across various sheets, but also multiple dashboards all at once. The number of visuals that we can choose from a given dashboard is restricted to 20. So I'm just going to go ahead and choose all the related visualizations, and I'm going to click add here. What it'll give me is a preview of the data that we are looking at. Since it didn't select smoking status, alcohol consumption, and city, I'm going to select these columns as well, fields as well, and I'm going to add that data. What I can alternatively also do is upload a file, and from my local computer and have it right here. What we are seeing on the left hand side panel are the two data sources. Scenarios support almost 20 data sources for a given scenario. And uh, sorry, my bad. Scenarios support 10 data sources per scenarios. So these are the two data sources that we are using here, and only 20 visuals can be selected from a specific dashboard. The kind of file that we are attaching from our computer locally has to be either a .xls file or a .csv file, and it cannot exceed more than 1 GB. For each data source that we are seeing here, we will be, allow me to open this, we can even add alternative filters which are currently supported only for the string fields. So let's say country, I do not want to include my home country, let's say India. And I will click on apply, and it will not provide me with data or the rows that belong to country India. And so and so we can attach multiple filters, but currently they are only allowed to be attached on string fields. So each data source right here, we can add additional filters, sorting, and other parameters to it. And e- uh, each data source can support up to 200 columns. Now that we have some idea about how the data is plugged in, what kind of prompt we have given, let's quickly start with our analysis. When I'll click on an analysis, a thread will start. A thread is nothing but a vertical chain of blocks, and blocks are nothing but a pair of a prompt and a response. So what we are currently waiting for is Q to generate its own prompt for us. Or alternatively, if we do not like any of the prompts that it has provided, we can even describe what we are looking forward to analyze. So for here, our aim is to identify patterns, correlations, and alternative possibilities. So the prompts that we are seeing are going to be either identifying patterns or some correlations and what if scenarios. For beginning, what I'm going to choose is I'm going to see what is the average sleep duration for people with hypertension compared to those without any health conditions. So what we are doing is comparing and trying to identify patterns. Meanwhile, this question is getting answered and the block response is getting generated. I'm going to start a parallel thread. Since I wanted to also explore alternative solution, I'm going to give a prompt that kind of creates a what if situation or what if scenario. How would the overall sleep quality change if everyone increased their daily steps taken by 2000? And I'm going to submit the response, and I'm going to submit the question. What it'll do is it'll take some time to analyze the data that has been provided to it, analyze the question that we are trying to answer, and generate a multi-step response, which looks something like this. This is something that I pre-created, as it might take a little while to generate the response for us. So here the question was, how do diet types and smoking status and alcohol consumption contribute to sleep quality? And another what if scenario was, how would the overall sleep quality change if everyone increased their daily steps by 2000? And we can see that a multi-step response was generated for both these threads parallelly. For the first scenario, we can see here, for the first thread, as we can see here, it has prepared the data for analysis, and it has calculated some assumptions. It has considered that anything above 3 is indicated as a good sleep quality. Um, it created its own field average sleep quality score on basis of some assumptions that it made, and this score is something that it is going to use to perform the analysis that is required. A point to note here is average sleep quality score the is not a column or a field that existed in our data set in either the CSV file that we attached or even the data preview that we saw for the data sets for the visuals that we selected. So in the step 2, this is an important step here because what it did is summarize the result on what this analysis looks like, which is like it reveals that the non-smoker consistently have better sleep quality. It even analyzed like what data types show that there is a slightly sleep better metrics, as well as what level of alcohol consumption when an individual intends to take, they tend to have a better sleep quality. With that, it also generated with a visual response to us with some charts that would give us some idea with like binge drinker and like, for example, what this chart is trying to show us here is the average sleep quality score and the average sleep duration. As we can see, the average sleep duration for a binge drinker is not more than 5 hours, whereas somebody with none, um, or somebody who's a social drinker or uh, has tend to have some similar sleeping durations. As we can see here in the final response, and these are some other parameters that are getting visualized here, but what I would like to bring our attention to is this step 3, which summarizes all the results that were analyzed in the previous steps. um, Based on our analysis, what kind of smoking status allows, like what the difference is particularly in notable, because non-smokers consistently experience the best sleep outcomes with average sleep quality score of 2.36 and sleep duration of 5.15 hours. Now, since we have all this summary of results right from smoking status to alcohol consumptions to diet types, it also provided us with something called as unexpected finding. Even though diet does have some influence on the sleep quality, but it was able to observe that minimal variation was provided um, when it came to a better sleep quality and a better diet. So it was not able to find that exact correlation between these two. So it gave us some recommendations on about smoking cessation, alcohol moderation, and balanced diet. Now, these are the things that were not provided to it, doesn't that were not fed to it. It generated these recommendations based on the analysis that it provided um, and the scenario we are question that we are trying to get answered. Um, for any given thread, so what this is just a block, and this is another block, and these two together form a thread. And we can continue building on the same thread below with any further deeper insights that we would like to get answered. But to be to put it in numbers, um, a given thread can contain up to 15 blocks, and each scenario, like this whole scenario that we are seeing here, it can have up to 50 blocks across multiple number of threads.